Cairo. Oh, Mauritius. That's Budu. Daniel from South Africa and so on. Uganda is represented. Zimbabwe. Botswana. Nonofo from Botswana. Zimbabwe. Nigeria. I need more people from Nigeria. Please pick the phone and call your friends to join. From Malawi, yeah, we are fully represented. I have only 87 people in the room. I need more. Wayne, please, if you can mute yourself, that would be helpful. Thank you. Republic of Ghana. Yeah, Burkina Faso is represented. Cameroon. So we are only 88. Please, guys, if you can pick your phone, call your friends, tell them we are going to talk about something very exciting today. It's about DNSSEC. You know, it's the most critical piece on the internet, and we need it to be very, very, very pretty much secured. And right now we have only 85 participants who has joined. We need more. Yeah, John from South Africa. Hi. I hope you are all doing well. Please, can you hear me loud and clear? I am rallying to have at least 100 people joining this session before I can start. We are still at 87. The race is still going. Oh, Pascal from Congo Brazzaville, welcome. Yeah, we are 90 and 10 more to go. Timothy from Kenya. How do we say Abari? Is that from Kenya? Is that Swahili? I don't know. My Swahili is too bad, you know. But I know I can say Karibu, and I can say also Akuna Matata. So everything is gonna be okay. Mata from Nigeria. We have Ahmed from Yemen, and we have Togo is represented. 5 more people to go. 4, 3. Okay, so we are there. Now, my name is Musa Stephen Honlue, and today we are going to be talking about extension securities for DNS, the DNS infrastructure. DNS stands for domain name system, and as I told you earlier, is the core of the internet. You know, without DNS, pretty much the internet would be a mess. It would be unable to really surf on the internet. Likely, every time you go on the internet, you must use the DNS. Like when you go on google.com, what happens? There is a resolution in the background. And this piece of infrastructure is very, very critical. So we need it to be very, very much secure. Last week, we had an interesting session on the kindness. It's an initiative also to secure the DNS. Today, we'll be talking about the DNSSEC validation. And on this panel, I have Yazid Ankaro and Mr. David Njuki. The two of them are going to walk us through the DNSSEC, what is it, how it works, and they will also do some sort of small demos, like testing if a system is signed and so on. So before we dive into the session, let me just remind you some few ground rules. If you have a question, if you have a question, please use the Q&A section. It's just below your screen on Zoom. If you have any other thing that you want to discuss during the session, please just use the chat. Make sure your questions are in the Q&A and any other topic is are in the chat. So to continue, let me give the floor to my esteemed panelists to introduce themselves. Let me start by Yazid. Yazid, please take 1 minute to introduce yourself, your background, and tell us some cool things that you do in the community.
Thank you, Stephen. Hi, everyone. It's really good to see so many people from different locations attending this session. And yeah, I'm really happy to share today's sessions with my dear friend David, and of course all of you guys. So I'm Yazid. I work for ICANN, Internet Corporation for Assigned Name and Numbers. We do coordinate what we call the Internet unique identifier systems at the higher level. What are those identifier systems? Very briefly, those are public IP addresses, autonomous system numbers, protocol port parameters, and also the time zone. People don't usually know about this part of ICANN, but this is mainly what we do. We do also coordinate the policy development process for all those identifiers. And my role is what we call the technical engagement, and I cover Africa and Middle East region. And within this role, I oversee the better understanding, right, of the internet standards and best practices by the technical stakeholders of the internet, meaning the ISPs, the network operators, the hosting providers, the regulators, the ministries, and all those entities that play a role in getting the internet working for the end users. That's all from my side. And yeah, I'm really looking forward to have an interactive session today again. With that said, back to you, Stephen. Thank you.
Thank you very much, Yazid. You know, our mission is to make sure that we have a robust platform, that's the internet in the region. And as we hear, Yazid, you are doing a very, very, very cool job. Please keep it up. Now, let me give the floor to David. Just one word about David. David has been working on very, very interesting, cool stuff on the internet. You've probably heard about RPKI. This is the guy behind RPKI system at Afrinic. He's installed a lot of the servers that we use to help you secure the internet. He's also done a very cool job on the DNSSEC at Afrinic, and alongside other servers that help the registry to sustain that strong internet for Africa. So let me not talk on your behalf. David, please say something.
Okay, thank you, Stefan. Hello, everyone. It's good to be here. It's good to see such a diverse list of people attending this. I'm David, as Stefan has said. My role in Afrinic is I'm a systems engineer with the infrastructure and security team. I think Yazid has already touched on Afrinic's role in the internet ecosystem. I will not say more on that. I'm really looking forward to share my experience and also Afrinic's experience with running DNSSEC infrastructure. I will touch a bit on the hands-on how we run things. Hopefully, we can all gain some knowledge after this session, and we will also be open for you to get in touch with us in terms of assisting in anything DNSSEC related, or even resource related in the bigger picture with regards to Afrinic and IP allocation. Thank you, Stefan.
Thank you. So this is how the session is gonna unfold. We start by Yazid. He's gonna deliver a presentation where he will walk us through the nitty-gritties of DNSSEC, and then he has a small demo for you where he will look at showing you how some of these features DNS that we use out there are implementing this cool DNSSEC. And then we will have question and we will have a session of Q&A. So while he's presenting, if you have something that you are doubting, a question on your mind, please type in the Q&A. And then after that, we'll take some questions, and then we move to David. David also has a presentation for you, and also a small demonstration on how we do it at Afrinic and how we participate in this chain of securing the DNS infrastructure. As we start here, we have 467 people Over to you, Mr. Yazid.
Thank you so much, Stephen. So let me share my presentation.
Okay, while you are sharing your presentation, we are also live on YouTube. So those who are on YouTube also know that if you have a question, you can use the comment section of YouTube to type your questions, and then we'll read them out to the panelists. Thank you.
Thanks, Stephen. I hope everyone can clearly see the slides.
I can see.
All right, so cool. Then let's go. All right, so let's start by the beginning. We probably all enjoy going to the internet, definitely, but we usually don't really know, or we less know about what happened behind the scene. So every time we open our browser and we type a URL, let's say www.afrinic.net or icann.org, before we get that page, right, the index page of the website, there are so many things that happen behind the scene, mainly handled by the browser and our operating system, right? And even some external systems that are even sometimes they are out of the network we are connected to. And the first thing which takes place is what we call the domain name system resolution process. Why? Because human, we are better in memorizing names, right? But all those devices that are interconnected, that make the big internet, they work with what we call IP addresses. They are like, let's say, phone numbers, right? And the same way we do not keep each and every person phone number, we just use the phone book, right? And we save the numbers. We link the numbers to a name, right? And this is what we save in the phone book. Anytime we want to call that person, we get in the phone book, we look for the name, and we launch the call. But behind the scene, the phone and the mobile network operator don't really use that name. It's the mobile number which is attached to the name that is used to establish the connection. And it's exactly the same thing. So on internet, there is a protocol, which is let's say the heart of the internet, which is called TCP/IP. And that protocol needs IP addresses to work. But because humans are not really good at keeping numbers, we now use that system to do the translation from names that we can keep very easily, like afrinic.net, icann.org, etc., to the numbers. And what are those numbers? Those numbers are the IP address of the server on which this website is stored, right? So the devices will now use routing and all of this to connect, to establish the connection to the server. So you can see that there are so many steps. There are different steps. And the DNS is the first one. Then you will have routing, and then you will have the HTTP or the FTP or the SSH, etc., protocol at the application layer. And this is how it works. Whether it is human who are trying to get to connect to a destination or to a remote server, or the systems themselves, right? So the operating system, the different applications that you use on daily basis, like emails, like you want to watch a video, even when you wanted to connect to this Zoom, you just click on the URL, right? But the Zoom server is hosted in an IP address in a remote server somewhere, probably in the US. So this is how it works. And that makes the DNS one of the critical services on the internet, because everything, literally everything starts by the DNS on the internet. One could imagine today's we have what we call distributed systems. Even when you open your browser and you type in this again, www.afrinic.net, there have been some researches that were done and which show that there is an average of 80 to 100 individual DNS requests that are made to allow you get all the landing page of a website. So you can easily imagine how critical is the DNS. Without the DNS, you cannot get the right resources on the internet. This is how it has been working since 1983 now. So the DNS is 40 years now. But over the years, unfortunately, this is how it also works for almost each and every technology. There are always, bad actors who try to use that technology for let's say, different purposes, right? So we always have the yin and the yang, right? And yes, those bad actors have used the time to improve also, to get sophisticated techniques to conduct their attacks. You have probably heard about those what we now call the DNS abuse, right? I want to really go into the details of that, but you hear about all those phishing, spams, botnets, command and control, etc., etc. You connect to a website and your device gets attacked, right? Because it will automatically download a malware on it. We have heard about ransomware attacks, etc., etc. So people are using intensively the DNS to conduct very bad activities. And one of the challenges of these attacks is because people are using the weaknesses of the DNS, right? So it is very easy, and if we had time, usually we demonstrate that in the trainings, like 4 or 5 days trainings. But here we can't really conduct such a exercise. But it is very easy to connect to a DNS name server and to manipulate the resource records there, right? And this is what the bad actors do usually. Or they also connect to what we call the recursive resolver, and they just, modify the cache data which is stored there. Remember, the recursive resolver is that a DNS server located in the internet service provider network, which is responsible of providing you those IP addresses we mentioned at the beginning. So at the technical layer of the internet, the technical community started in the 90s to think about how to secure the DNS. And of course, securing the DNS is a very huge task. And as usual, there is no single, technology that can secure everything. It's exactly the same for the DNS. So we now use different technologies together to improve the overall security of the DNS. But today we are going to talk about one of them, which is called DNSSEC. And DNSSEC stands for Domain Name System Security Extensions. So basically what it does, it uses the public key cryptography to generate what we call signatures, right? So it's exactly in normal life, right? To prove that you are the owner of a document, you sign it using your own signature. Anybody who gets in touch with that document, look at the signature and can confirm that, yes, you are the one who generated that document. In digital and world, it's almost the same thing, right? So one entity will use what we call a private key, which must be private, not shared with anybody. Use that private key to sign it can be a file, it can be an email, it can be whatever it is. So we use the same technique in the DNS to now sign the DNS resource records, where we sign those DNS resource records where the zone file of the domain is stored, right? And on the other side, we do what we call the validation. We basically verify those signatures exactly again as we do in the normal life, right? But now it is everything in the digital world. And with such kind of mechanism in place, we can now help prevent some of those threats that the DNS is going through, right? Most of them are the DNS cache poisoning. So if anybody now tries to modify the data which is stored in the cache of the recursive resolver, if the DNSSEC is in place, it will prevent such kind of modification. On the same way, if someone tried to hijack a DNS authoritative name server where all the resource record, all the information for the domain are stored, and try to modify a record there, because the domain is signed, of course, if it is signed, the network, the infrastructure will be able to detect such kind of modification and will prevent the user to continue using such kind of information. And of course, doing that, we are increasing, right, the trust on the overall internet, right? So one can see this complementary to the SSL, right? So SSL is used for websites to encrypt the data between the web client and the web server, right? To protect your password, to protect your username, to protect your bank account information, etc., etc. But before getting to that website, the DNS has taken place. So if someone was able to hijack the DNS, he will be able to redirect you to a wrong destination, which of course will look like it will look like your real website. You will trust it because, again, eyes will not show you anything, and you will share your personal information there. As soon as the attacker gets all those information, he will now connect to the real website, modify your password, and he gets control of your information, right? But for that DNSSEC work to really, DNSSEC to really work, there are two actions that are required. The first one is called signing the domain. So the domain owner or the domain administrator, let's say for afrinic.net, David will show us later on how they have signed the afrinic.net domain, right? And how they have generated the signatures, how they maintain all this infrastructure to make sure that over the time they renew the keys, etc., etc., right? And on the other side, because the domains are signed, we need to verify them. We need to turn on that specific functionality on the DNS recursive resolver software, which is called the DNSSEC Validation. It is exactly as if you put a security guy at the gate and you tell him, hey, guy, look at the ID cards of each and every person who will be entering this place, right? So if the person doesn't have an ID card, don't let him in, right? Let's say there is a big football match in, let's say, in a stadium. So there is a step where they sell tickets, right? But the day of the competition, of course, there will be security guys who look for each and every ticket just to confirm that those who are entering the stadium actually have the authenticated tickets, right? Because, you know, there have always been a bad market where people sell fake tickets, etc., etc. It's exactly the same principle. So on one side, someone is responsible of putting the additional information that can help later on to authenticate the right from the fake one, right? And it's exactly like banknotes as well, right? So you enter a supermarket, you buy, you pay by banknotes, but the person will verify the banknotes, each of those banknotes, to confirm that they are authentic, right? It's exactly the same principle, but here everything is done by the DNS systems. So for companies and business who own domain names, they should sign their domain names. The root zone is signed since 2010. And if they have recursive resolvers, they should also think of activating that DNSSEC validation to do the control. So if all the domains are signed, but nobody is doing the validation, it's like as if nothing is done, right? On the other side, if everybody or all the recursive resolvers are doing validation, but nobody has signed the domains, of course, there is also nothing to verify. So those two mechanisms are important. They work independently, but they complement each other, right? And of course, for ISPs and mobile network operators, the first main DNS server that they provide is usually recursive resolvers. So for them, it's really important to turn on validation. But if they also have their own domain names, or if they host domain names for customers, they should actually think of signing those domain names for the customers. For signing, it is quite a huge task, a lot of things to consider. I won't really get into the details here, but we should think of the infrastructure, plan everything, right? Think of the software that will be in charge of signing the system, generating the keys as well. There are some dedicated devices that help generate strong keys, and also to store them in a very secure manner, etc., etc. So there are really a lot of steps for signing, and when everything is controlled, well documented, it is usually a very straightforward process. But for validation, it is the easiest part, right? You just get into the recursive resolver and its configuration. You put the instruction to actually tell it to do the validation. And again, the validation are just some controls that are done. If everything match, let's say the keys, the signatures, and the calculus that it will be doing itself, if everything match, then no problem. I'll serve the data to the user. But if during the verification, the recursive resolver notices that there is any issue, whether the signatures have expired because they have an expiry time, right? Or if the public key, which is published in the zone file, doesn't match with the private key that was used to sign the data, or any other kind of issue, there are so many possibilities of issue that can occur, right? So if for any of those verification, the recursive resolver notices that what it has verified doesn't match with the signature that came from the authoritative name server, it will stop there and will not serve the answer to the user. That way, of course, the user will be prevented from being redirected to the wrong destination. And of course, an error code, the kind of error code will be sent to the user just to tell him, oh, I got a server failure. I don't know, I can't tell you what exactly happened, but yes, I can't provide you with that answer because something is wrong here, right? So what do we need to enable DNSSEC validation? Because again, it is the easiest part of it, right? So to enable DNSSEC validation, if you run your own recursive resolver, again, even if it is an open source or a commercial recursive resolver, most of those software today are now validating by default. So today, if you download Unbound or Bind or any other open source DNS recursive resolver software, by default, the likelihood that they have been validating is really high. I know by experience that at least Unbound and Bind do it by default. Now, in the past, they were not, but you know, it is a common objective of securing the internet. So the IETF, when they publish all those standards, we on the technical community make sure that, you know, all the different stakeholders understand what is their role. And for DNS software vendors, there have been a lot of discussion, and they understood that they should update their softwares, right, to enable the DNSSEC validation by default. But there is still a lot of work to do because in our different networks, we have servers that are there running since many years, right? Without sometimes even without getting updated, etc., etc. And this is where the challenge is. I will show you later on the statistics, right? If you go to this website from Epinic, you can get the statistics per country and even per network of the ratio of DNSSEC validation. And you can see with that platform that there is still a huge work to do in terms of improving the overall status of DNSSEC validation. Today, we are around 31% of DNSSEC validation around the world. And of course, in our strategic, in our 5-year strategic plan, 21-25, it is mentioned that we should work intensively to increase the DNS adoption. And this is why we are doing so many projects and running different kind of initiative to reach out to network operators and make them understand what is their role, what are their responsibilities in, you know, increasing that ratio. So these statistics have been pulled from the website stat.lab.epinic.net. You can go there and play with it. It is very interactive. You can see for your respective countries what are the statistics. And of course, as far as Africa is concerned, 3 years back, I can tell you, trust me, almost everything was like yellow and red, right? But because we did a lot of work with internet service providers and mobile network operators in different countries, we are getting a lot of progress. And we really look forward to continue working with the respective service providers and support them until we get to better results. Right now, we have countries like Nigeria, Mali, Senegal, Sudan, I think Zambia, etc., and of course Madagascar, Egypt. There are so many countries where we still have a lot of challenges, and I look forward from those who are attending the session to also help us. Drop us an email if you need support and you wanted to be helped in turning on DNSSEC validation. But definitely we need that to provide a better internet. and a safer internet for everybody. And of course, as I said, just drop us an email and we will be happy to support you. We have a lot of activities in terms of trainings, hands-on guidance, of course, sharing documentation, etc., advising in parameters also. I've been doing that since the last 3 years, and it's a real pleasure for me to get in touch with different people from different networks, to see also and to learn as well from them. Because when you talk with someone in Morocco and you talk with someone in Cameroon, the challenges are different, you know, and it's really a pleasure, and I'm more than welcome to continue on that direction. So now, for those who are attending this session and who manage DNS servers, are you interested in activating DNSSEC? Not only validation, but even to sign your zone, right, to secure your DNS data. And if yes, then let's work together, right? So again, for DNSSEC validation, I think I already covered that. This is the high-level overview of the devices. So on the left side, you have your phone, or it can even be your laptop, etc., right? So it will be sending all the DNS queries to the recursive resolver if on the stop resolver there is no answer. The recursive resolver is responsible of, you know, talking to different authoritative name servers until it gets the answer. And then it will, of course, store a copy of that answer in its own cache to faster the process in the future. And it will provide the answer to the user, right, to the requester. Now, with DNSSEC validation, the difference is that there are some additional piece of information that make the recursive resolver inform the authoritative name server that I will do the DNSSEC validation. So if you have public key and if you have signatures, give them to me, as well as the DNS, the clear DNS data that I was looking for, right? So once it gets all those information, the DNS answer plus the signatures plus the public keys, it will do the verification on its own resources, do the comparison, and if everything's matched, it will now send the answer plus the authenticated data to the user. This is the piece of information, the AD flag, that actually confirms the user that, well, the data I receive is authenticated. It means that it has come from the right source, and it has not been tampered by anybody on the path to me. So to enable DNSSEC validation on recursive resolvers, I will touch 3 of those recursive resolvers we have seen most used in the community. The first one is Bind. Of course, Bind can be used as a recursive resolver or as an authoritative name server. I hope that in the future they will split the 2 functions, because this is now the trend. Or if you look at almost all the other DNS software vendors, they now split because of security purposes again. So there is only one line to add in the bind configuration in etc bind name.conf.options to turn on DNSSEC validation. It is DNSSEC-validation space auto, and of course there is the semicolon at the end. This is how you are telling bind, oh, you know what? Do the DNSSEC validation and in auto configuration mode. Because there is the yes option and there is the no option. If you put it as yes, you are forcing, or you are telling BAN that you want to control everything, especially on the root zone key, what we call the trust anchor. It is quite, let's say, I won't say dangerous, but if you know what you are doing, you can put it to yes. But you know, in 2018, we had a major change on the root zone. We changed the KSK. And if you put it as yes, if you don't download the new key, the new trust anchor, you are putting yourself in trouble because all the DNSSEC validation will now start failing. So better for you to put it to auto, and the software will use a protocol which is called the RFC 5011 to automatically download the active trust anchor at the root level. In Unbound, it is also quite easy. You just uncomment one line in the configuration. You run the Unbound anchor. It will download the latest root trust anchor, and you are done. But the good news is that, as I said before, all those recursive resolvers are now validating by default. So if you download the bind or Unbound software today, it will be doing validation by default. But again, for those who are running those systems since 5, 6, 7 years, please go and check in your systems if your recursive resolver is doing validation. If not, you now know how to do it, right? And if you turn it on, please do the verification to confirm that you are now getting that AD flag, right? That AD flag is really important to verify. With that said, I'm at the end of the presentation. If we maybe have some time, we can quickly do 1 or 2 queries with an open recursive resolver just to see how to confirm that the resolver we are using is doing the DNSSEC validation or not. Thank you, and back to you, Stefan. If we also have time, we can even go to the Epinik Stat Lab website just to also show people. It is not to blame anyone, but at least if we get people from Nigeria, I hope that they will show up and they will volunteer to improve the statistics in their country, as well as other countries we are also having challenges. Thank you, and back to you, Stefan.
Hey, Nigeria. What about Nigeria? Why did you specifically name Nigeria? Why? Tell us something. Yeah.
Oh, well, it's because they are very big, if not probably one of the biggest countries of the continent. And I'm pretty sure that if we change the figures in Nigeria, we change the figures in some of those key big countries in the continent, Africa will now be seen as the most validating continent in the world. And that will be, of course, a good for all of us, right?
All right. So that's one of those quick wins. So I hope guys in Nigeria, you are hearing us here about securing your DNS infrastructure. So if you have questions, please type in the Q&A. I think I have some. Let me see what we have there. Do you offer organized personal workshops? Is Infoblox a competitor for DNSSEC? Yazid.
Oh, Infoblox is a software, is a DNS software vendor. So they provide graphical systems which make it more easier. And I have seen a lot of operators migrating to Infoblox because it offers graphical systems, but it is not a challenger to DNS itself, unless I have misunderstood the question. So it's a software as bind and unbound and Power DNS, etc., etc. By the way, Power DNS also has a graphical interface for the authoritative name server, but Power Recursive, the recursive resolver software from Power DNS, it's only command line.
Okay, all right, merci. So there are some who are looking for trainings. Henry is looking if there are materials on DNSSEC on how to implement. So Yazid here, this is Yazid's work. So if you get in touch with Yazid, he can help you to turn on DNSSEC on your DNS infrastructure. So Yazid, please share your email. Yazid, David, please share your email in the chat so that these guys can reach out to you for support, please. Name server is a server used in the DNS procedure for name resolution. This is Valempini. That was most of a declaration. For labbing platforms such as GNS3 on Cisco Packet Tracer, when can I find DNS related labs that can? So yeah, so all of you who need support, please, we have Yazid's and David's email in the chat. You can reach out to them. And we also have an expert in the forum, that is Mark Eklins. Mark Eklins, if you can share your email for those who need support so that they can reach out directly to you. With that said, if we have no more questions, I see two hands raised. Aaron, Bekaye Sise, please, if you have any question, please type in the Q&A. Now, if you have any questions, please type your questions in the Q&A. I did not have asked people to share their emails. I see everyone is sharing their emails and so on. I just asked to those guys there, that's Mark Eklins, David, and Yazid, please share your email so that people can reach out to you for more support. So without any other form, let's move to, can we have a specific support to implement DNSSEC in our network? Yeah, you have Yazid here and David. So if you reach out to them, they will help you. Sure.
Yeah. So very briefly, we don't configure things. We don't connect to the infrastructure, but we provide hands-on. We provide training, as I said. We can also work with you on your test bed. I have done that with some of those operators. We can have some Zoom sessions where you will be in charge of everything. I will be watching, and yeah, that's it. And it works. It works.
Okay, good. Yeah, so support, not going to connect to your servers. So I have DNSSEC validation in my DNS. Is this okay? Is that all I need?
I think he said he has DNSSEC validation. Yes.
Yeah.
Okay, so if it is yes, it will work. But when we do what we call what's the name of this process again? We change the key signing key at the root level, right? So we do a key rollover, right, at the root. He will be in trouble because if he doesn't download the new key from the root zone, and that key become active at the root level, all the DNSSEC validation on his side will now start failing. But if it is put to auto, the DNS software itself will now download the latest key and everything will be running automatically without his manual intervention. That's the difference between yes and auto. So to make it more secure, put it to auto, and you will be in safer position.
All right, thank you. So next question is, which protocol do DNSSEC run? Is it a UDP or TCP, and why?
Good one. So DNSSEC, actually, it just adds a layer, let's say some additional extensions to DNS. So nothing changed on the port 53 by default, on UDP or TCP, nothing changed. But there is something important here, which is called the eDNS, extensions for DNS. It actually allows the DNS packets to be larger than the 512 bytes, the original 512 bytes by default. And for those who attended last week's session, I think it was Mark Elkins who mentioned that one of the servers was not responding to eDNS. it's extremely good, important to make sure that this eDNS is also active. And I think the recommendation is to put it to 12, 13 or something like that packet size, still to keep UDP, to avoid the TCP fragmentation. So it's a long debate, it's a lot of discussion, but to make it short, DNSSEC doesn't change anything on DNS protocol itself. It still works on the port 53 by default, UDP or TCP, both can work. But please make sure that you have eDNS. And if by default you do your software upgrades every time, you should be running the eDNS by default as well.
All right, thank you. What is the difference between DNSSEC and DNS Curve?
I don't really like to enter that debate, but DNS Curve is totally different. And even there is still a lot of discussion around DNS Curve. It is not even really well deployed. I'm not sure if this has progressed at the IETF, but I know there have been some operators pushing for DNS Curve. But what is adopted as a standard is DNSSEC. And this is what we know as the only, the single protocol that helps prevent against cache poisoning and IP spoofing or redirection to wrong destination on DNS.
Okay. Notice Yazid mentioned excluding forward zones for DNSSEC. How does that affect the validation?
Sorry, I missed the.
Yeah, so you mentioned excluding, where is the question again? Hold on. Yeah, you mentioned excluding forward zones for DNSSEC, right?
Yeah.
How does that affect the validation?
Okay.
This is a question from Solomon.
Okay, so the forward zones, usually we do that because we want the recursive resolver to go to our internal zones, right? Instead of going to resolve on the internet. So when you want to do the DNSSEC validation, so DNSSEC validation auto, you can use that specific parameter just to tell the recursive resolver that, look, I have some internal domains and no need for you to do the validation for those domains. This is where we use the forward zones to inform the recursive resolvers that to exclude those internal domains from the validation.
All right, so thank you very much. There are some other questions we will take as we move. I would now like to invite David on stage to deliver his presentation. And then at the end of this, we'll still go back to the Q&A. Thank you, Yazid, for that, for the brilliant answers.
Thank you, Yazid. Thank you, Stefan. Let me just share my screen. Can everybody see my screen? Can you see my screen?
Yes.
Okay, great. So thank you once again, Yazid. I think you've touched on a lot of aspects for DNSSEC. On my side, I think I'll just now demonstrate how we're doing it in Afrinic. So Afrinic and reverse Afrinic and DNS. So we are a regional registry, so we do deal with numbers, but our role also comes in with DNS in terms of the reverse DNS. As you can see, we have shared our reverse DNS zones. For reverse DNS, the top level domain is .upper. So I'm sure if you're familiar with let's say, email servers, what you do is you have to put your PTL record in your reverse DNS zone, which is quite important because otherwise some email servers will not, a lot of email servers will not accept your email. So for this, I've done it in two parts, the IPv4 and IPv6. But then now what I will do, I will narrow down to how we are doing it as Afrinic. So keep in mind that there's Afrinic as an RIR and then Afrinic as, as a business entity. So we also a member of our own organization. We have our allocated resources. We do apply for resources just like any other member. So we have to justify, we go through the same process. We have to practice what we preach. We have to use these resources with some of the services that let's say all the services that we provide to members. This includes zone signing, this includes RPKI, this includes IRR, all these services. And these are available when you become a member. These are available through your login, when you log into the MyAfrinic portal. So as you can see here, I've put two of our resources that we've allocated on our infrastructure. One of them is the 196.192.124.0/24, and you can see the corresponding reverse DNS zone. It starts in reverse. That's the reverse zones with the upper extension. The V6, we also do have a IPv6 allocation. That is also now the corresponding zone. So to dig, to get the reverse zone details, dig is a common tool we use in DNS. So we do the -X flag and the IP to get the corresponding reverse zone record. So as you can see here, Yazid was talking about the AD bit. So I've highlighted that bit to show that this zone is signed, because now I've allocated the .146. We've allocated, let me not say that. We've allocated the .146 IP to our MX record. So the pointer record to the MX for our mail exchange. We do have a record that corresponds to that. This is just a simple query for that. I just wanted to, the only part that shows DNSSEC here is the AD bit that Yazid had mentioned earlier on. So for DNSSEC operations, I'll just continue to add on what Yazid had said earlier on. So we do have operations. When you decide that you want to sign your zones, there are various operations that are involved, keeping in mind that you need to be running your own authoritative servers. On the user's end, when you want to enable validation for your end users, it's the easy part. But now for the other bit where you enable DNSSEC for your zone and you're hosting your own name servers, you do have now more operations involved. So I've highlighted some of them here. First one includes the zone signing. So you have to, this is good for a lab environment. You have to try out different software that is out there. There are some which are easier than others. I would suggest trying out this in a lab environment. This is what we've done on our side. We do various lab tests. You will get to appreciate more how to enable the zones signing, and you won't be able to do the last bit, maybe to upload your key to the parent, but you'll be able to understand the different operation methods. So on our side, as a registry, we do have, out of the initial zones that I shared here, the 4.1, 196, and the V6, these have already been signed within our infrastructure. And the parent for these zones, so in DNS delegation, we talk about parent to refer to delegation. This is a good analogy. So it's parent and child. So our parent for the 4.1, 196, 154 is the in ADDR, and IP6.upper. So one for IPv4, the other one for IPv6. So we do have mechanisms and system to upload those keys. That is obviously will be beyond this presentation. I just wanted to touch on that. Keeping in mind that also now for your forward zones, let's say you have your .co.ke.ng, there are also mechanisms by this registrar to upload the delegation signer records into the parent zones. So this is what now is sort of established the link between the parent and the child, and eventually up to the root. This is what is called now the chain of trust. I'll touch more on that later on. So part of the operation is not only uploading keys. You also have to monitor your zones, right? So internally, we also do monitor our zones because keys have a lifetime, and you need to be notified when a key is about to expire. I think for those who have been in the DNS, watching the DNS space for some time, we've seen that some keys have expired for some country level domains. So usually there are people out there who are monitoring. Even if you don't monitor yourself, you might become famous for allowing your keys to expire. You don't want that to happen. So key management is also quite an important part of the operation, not only on DNSSEC, but on other PKI related public key infrastructure. Yeah. So what that does is, the most important thing here is trust. So with the security is a chain of trust. So when I've generated my keys here and I upload to the parent, it's because I trust the parent. But now who trusts the parent? So you go further upwards to the relationship. The parent of this in-addr.upper and IP6.upper is .upper. .upper is a top level domain. .upper is a top level domain like your .mu, .za, you know. So from now, from that top level is the root. So you go all the way up to the root. But who trusts the root? One might ask. So the root is explicitly trusted. So the root is explicitly trusted. We do have some ceremony where individuals are selected from all over, from different parts of the world, trusted individuals, not just any individuals, for this operation of the root. So yes, that is from the reverse part. I wanted to also mention that internally we have enabled validating resolvers for all our infrastructure. So this is the entire infrastructure in terms of systems, and it is also our corporate network. So our corporate network is the office. So in the office here, our validating resolvers, we've enabled DNSSEC. So I'd also like to mention that Acrylic.net, our primary domain, it's DNSSEC signed. And just a final point on this slide is that all our reverse DNS zone data is published on FTP. The link is there at the bottom. So the next slide, I'll touch a bit on the keys. I'm sure you've been hearing key here, key there. There is a lot of keys. So initially, when I started learning about DNSSEC, the keys were really confusing, and there is no other way. You have to understand how these keys are. There is no two ways about it. So I've just given a brief description. I'll try to explain it the best way on how I understand it. So you start with you want to enable DNSSEC in your infrastructure. So the normal DNS, the resource records are plain, right? So you want your zone to be signed, because you start with a zone. And for you to sign your zone, you have to be running your own authoritative name servers. So keep in mind now, for you to run an authoritative name server, you also need an IP resource, which is where Acrylic comes in. If you're a service provider, most of you are already members. If you want to run it with your own on your own, you need a public IP address for this. This is where we come in. You can always get in touch with us to advise on that. So now when you have your name server, you're doing your normal DNS, whereby I'm serving my A record, my WW record, I'm pointing to the different services. But now I want to go a step further to sign my zone. So signing the zone is in two parts. Yazid had already mentioned the first, these two parts, but I just want to touch and emphasize on the importance of this. So the zone, there is a zone signing key pair. So this is public-private. So the zone signing key pair signs the resource records within the zone. So resource records, it can be one or it can be a set of resource records. What do we mean by a set of resource records? A set of resource records, let's say, it can be an MX. When you say MX, MX1 points to this, MX, it's a set. But a single resource record can be an A record. You see, A points to this IP, A points to another IP. It's an individual. It can be distinguished as individual. So once this resource record is signed, it's now can be defined as to have a resource record signature. So this is a signed resource record. It's in DNS, it's referred to as a resource record signature. Now, on this part, now, because you're doing the signing, you're signing the records, there is a signature, you need a key. This is now the key that is, you have public and private, the key that is made available for verification or validation by your resolver. It's called the DNS key. Now, it doesn't stop there. You've signed your zone and all that. It might be safe, but now in the whole infrastructure of things, because you're making your information available to the internet, how do you ensure that this signing is trusted? So what happens now, your zone key, because now this is where now the chain of trust comes in, the DNS key that is on your zone key is signed again by another key. So you do have a zone signing key and a key signing key. So the key that is that signs the zone is also signed by another key. So it's good to appreciate the two parts of it. So the second key is what now is used for the relationship with the parent, because now this key, once it's public, it's sort of the same process. I don't know how to simplify that part. The zone signing key and the key signing key are the same, but now what happens with the key signing key is that it is hashed and uploaded to the parent as a delegated signer record. So this is where the relationship is between now the parent and the child to establish a chain of trust. I've given an example there for Afrinic.net. So all these records that are highlighted in bold, you can do a dig, except now for KSK. This is further details on the output of the dig results. You can see I'm doing a dig for Afrinic.net delegated signer. I want a short output. You can see that there is this PKI cryptography kind of data output there. So on your end, you can try these other dig examples. We know Afrinic.net is signed. I know ICANN.org is signed. You can try to get the output and see very interesting output on that. That is how it's a fast appreciation of that a zone is signed. When a zone is not signed, you will not have this output if you do dig with these other flags. So all these keys and resource records are defined on RFC 4034. You can read more on this to get to appreciate that bit. I'll move over to the next slide. So now we were talking about chain of trust. I think visually now you'll get to appreciate now this bit and where Afrinic will come in, and through now the Afrinic as a member, Afrinic as an RIR, and the other bits. So you can see the chain of trust is top bottom. You can see the DNS route that I was mentioning there. We delegates to .APA, and there's other in forward zones that can be your .co, .eg or whatever. So I will highlight on the RIR bit. So it's still in yellow, like the first slide. That is our 196 Afrinic allocated resource. And further down is that is an Afrinic as a member. Remember, I showed you the 124 IP resource and its corresponding reverse record. So what happens on us as a member? We go into my Afrinic, then we delegate our NS record. This is the first part. Delegating NS record means I'm saying from Afrinic, I'm pointing my DNS server. I manage my own DNS servers. I point it to my DNS servers. I'll show you how that is done through our Afrinic portal. So that is the first part. A lot of members already do this. A lot of big operators are running this. If they're the ones who have not enabled DNSSEC are doing this. The second step, if you are now enabled DNSSEC signing for your reverse zones, you will need to update the delegated signer records on the same portal, because see Afrinic as your the portal is like it's the same process as the parent and child relationship. You run your DNS servers are the child, the 196 upper is the parent. So this is through the MyAfrinic portal. This is where you establish that relationship. So I'll move on to the next slide. So with the DNS, just like the forward zones, all these objects are in the WHOIS. So I just wanted to give an example of the 196. If you do a WHOIS, this is part of the data you will get. You can see the different WHOIS information that is there. So for reverse DNS, we deal with domain objects. So you can see the domain there is defined. The end server, it's good to appreciate that we have several end servers there. If you attended last week's webinar, remember that for kindness, for DNS infrastructure, you're advised to have your name servers in a geographical diverse locations. So you can see here we do have secondaries where our other RIR colleagues post this same zone for us. And what's interesting for us here is the DS data object. So this is delegated signer reverse zone data. So this is what we've already applied from our DNS servers. We've already uploaded the DS records to the upper. This is where we've established the relationship. In this case, it's with IANA. So I'll also show you how the same objects now through a member's point of view. So now this is MyAfrinic portal. If you remember, you have access to this this kind of section of the portal. So you can see the reverse zone when you want to go to edit your zone. This is the reverse zone. The 124 is the example in this case. You can see I've put two name servers there. These are our authoritative servers. Keeping in mind, we don't run operations from those. We just push the information there. We do have the hidden servers because this is how DNS infrastructure operates. You do your operations from a hidden infrastructure, and then once that publication is done, you push it to your public name servers. And what's interesting here now is the part for the DS records. So you can see we've uploaded two records. There's 6265. I hope it's visible, and the other one is 10867. This is a key ID. So every delegated signer record has a key ID, which is a unique identifier for that resource signature. So now, once you do this update on MyAfrinic, immediately the update to WHOIS is usually it's immediate. It's within an hour. You will see that if you do a WHOIS query, your data is already on WHOIS. So you can see we've put a description there. So this resource, we use it for our Mobatha operations. You can see the name servers are there. So you can see the contacts, but also you can see what is the DS data, just like the previous record, which is now, this is different. I've done highlighted the red one because this is what is active right now. The other one is the 6265. We're supposed to remove it. So what happens why we have two is when you're doing a key rollover, you would want to have two records in place, because when you have two records, it means there is a transition. One record can be a single point of failure when you're doing a rollover. So we did upload this. This was recent. So we need to remove the other one. When this other one expires, we do also the same transition. Like a few days before, we upload the new key. Once the new key is active in the chain, in the full chain of trust, we can remove the old one. So this is just an explanation of that parent-child relationship. I will not repeat on this. It just touches on what I've explained previously. And then now validation. So we want to use DIG to see these records now. Like anybody can validate. This is your resolvers and whatnot on the internet. So you can see I'm doing a DIG. DNS key. I had mentioned earlier on about those resource records. I'm doing it with one of our internal servers. You can see the plug is already showing the AD bit, which means it's a validating resolver. And then the answer section has interesting stuff now, right? When you do a DNS key, you can see DNS key 256. So the key ID is not a key ID. 256 actually means this is a zone signing key. And this is the corresponding algorithm, which is RSA SHA-256. Key ID is there. So when you do a DNS key, you'll get both the KSK and the ZSK, which I have highlighted on the next section. Keeping in mind that on our 124 zone, when we were editing our DNS, we had two records. So those two ZSK records are available here. Remember there was the 42419 and that's a different part. Sorry. Yeah. So those two records are available. I'll show you. Maybe if you have time, I'll show you now how to get the specific key ID that was there on MyAfrinic. So validation, we also have validation tools out there. One of the more popular one is called DNS Viz, which basically means DNS visualization. So with this, you will also get to appreciate the chain of trust, and it has very nice visualizations with different figures, you know. I've just cut a bit of it because the whole thing could not fit. But if you go to the site and you put if you put Afrinic.net, any zone that is signed, it will show you a very nice top-down tree on how the validation works. And with that, I think I'll just touch on one last bit, which is some of the adoption in terms of signed with reverse DNS zones. Yazid mentioned the other one for, I don't have a fancy map of Africa, but we just pulled some data from what we have signed through the MyAfrinic and WHOIS. We are not doing very well in terms of reverse DNS signed zones. I think we could do better. The numbers are still low. And I think part of such sessions will create more awareness. And we also want to, you know, always try to embark and share our experience and learning from us. Maybe we will get more people to adopt. So it's not only on the forward zone, also on the reverse zones. And together we can build a more secure internet. Yeah. So I'll stop there, Stefan. If there are any questions, I'll be ready to answer. Thank you.
Thank you very much, David. Always very interesting to hear from you for all of this nice work that you are doing for the continent. So let's look at the Q&A if we have questions. So if you have any questions, please type in the Q&A. If you have any other thing that you want to share with regards to the topic or whatever, please type in the chat. Those who are on YouTube, you can use the comment section to type your questions. So let's start from the end. And I have Kevin. Kevin is in the house and he's having a question. What are the main reasons why many CCTLDs in Africa have not implemented DNSSEC? I missed the first part. So Yazid, please, do you have something to share about that?
Well, that's a deep question. There are a lot of reasons. Right now, we are running a project which is called the Coalition for Digital Africa. And one of the projects of this global initiative is, in fact, let's say, to revamp the DNSSEC roadshow to support some CCTLDs in implementing DNSSEC at the CCTLD level. So today, out of those 54 CCTLDs, we have like 19 of them that are really assigned. I think there are 3 or 4 of them that are signed in the zone, but they have not shared the delegation signer, as David explained us, with the root zone. And without doing this, they are not fully DNSSEC. When you look at the operational level, you see a lot of gaps. To be honest, there is still a lot to do. And usually this is the biggest challenge of our CCTLDs. Not only the CCTLDs. Usually when I do the trainings, people ask, well, with this DNSSEC, we can't really run the DNS the same way we were running it before, because we just forget the system there. We have so many issues with other systems and the DNS run on itself, right? But with that DNSSEC, you have now all the key management, which is a completely separate topic. You have to be monitoring your signatures. You have to improve your operational posture. And this is where the biggest challenge is. Most of our CCTLDs do not document things. And when it comes to DNSSEC, documentation is a key. It's a must. Now they feel like we are getting pressure with that DNSSEC, and this is something we don't want to go into. That's what I can briefly say as one of the reasons.
Yeah,
so
as
it's
a follow-up on that,
a matter of fear more than anything else.
Yeah, as a follow-up on that question from someone else, I would like to enable DNSSEC on all my zones and hosted zones. But I'm thinking, why should I do it? Since most of the TLDs and the top level domains are, so since the country codes and the TLDs are not even signed yet. So can we tell them, direct the TLDs on how to do this and why it's important?
Yes, that's true. That's true. If your CCTLD is not signed, unfortunately, you can't sign, or at least you will sign, but it won't be active. And I think someone else also asked the same question, and he pointed to DNS look-aside validation that was in place back in the time when the root zone was not signed, right? But the root is now signed since more than 12 years now. And when you take the GTLDs, they are 1,200 something. They are all signed. All the generic top-level domains are signed. But the issue is still with CCTLDs, right? So I think the right approach will be to continue outreaching to those CCTLDs, explain them that in this life, security is a real concern, right? You can put all the firewalls you want. You can put whatever you want in terms of user authentication, but the only thing that you can do to protect your online presence by securing your domain is deploying DNSSEC. There is no other solution today for that. Of course, we will talk about other kind of security mechanisms to protect your domain information at the registrar and at the registry, but this is another topic. But at operational level, please sign your zone. Now continue pushing your CCTLD to also sign the zone. But even if the CCTLD is not signed, you can sign your .com, .org, .net, .africa domains, right? So look at your registrar or where your zone is stored, right? If you have a hosting provider who is managing your domain, just get in touch with them and see if they can sign your DNS resource records. And if you are hosting yourself, or if you are hosting on behalf of customers, you can still sign for the domains, even if the top level is not yet signed.
Okay, thank you very much. David, is it actually possible to activate DNSSEC without modifying the infrastructure, David?
Thank you, Stefan. Yeah, I've seen that question. Yes, the quick win here is to activate the validation. So I think Yazid had mentioned this. I would not say without modifying the infrastructure. It's turning on validation is quite important. Think of it as DNS plus, you know. Your normal queries, if the zones are not signed, it will not be affected. But if the zones are signed, there will be validation. So if someone tries to do something funny on those signed zone, they will not be validated. So that's a very important step. And it doesn't really affect much if you're running your own your own caching resolvers. Already, I think we spoke about it last week. Most of the public ones, they do this. The Quad 9s and the Quad 8, yeah, they do this.
All right, thank you.
I want to also add to what David just mentioned on the signing part. And I think in my presentation, I also briefly covered that. So when it comes to signing, one should ask yourself, do I want to dedicate, let's say, hardware to sign my zone, or do I want to sign, the signing function to also be part of my current, let's say, primary name server? Those DNS software vendors like Bind, they have been always trying to improve and to make it much easier also to deploy the technology. So back in the time, like I'm talking about 2006, 2010, it was only manual signing, right? There are some commands you have to type, etc., to generate the keys, to secure the keys, and then to sign the zone, to refresh the signature, etc., etc. And then there was what we call now the semi-automated procedure, where you still generate the keys, but you tell Bind to auto-maintain, right, the zone for you. So it has access to the keys, and it will do the signing and the zone refresh for you. And more recently, I think 2018 or 2017, in Bind 9.16 or 17, I think, now they have implemented the policy. So you write a policy on which you can set all the instructions to generate the keys, to refresh to renew the keys, and to refresh the signature, the refresh period, the resigning period, etc., etc. In that policy, you can put everything that you want, and it will do almost everything for you. Even now, we have reached a new step where even to publish the delegation signer with your parent, now you can even automate that if your parent allows it, right? So in the past, you have to, even if you automate all the process in your zone, for sharing the delegation signer with your parents, or to update the delegation signer because you did a key rollover on your side, you had to do it, let's say, manually. But now with those new resource records we call CDS and CDNS key, if your parent allows it, it will be looking at your zone, and that CDNS and CDNS key will tell the parent that, oh, I did a key rollover, please come and fetch the new delegation signer. So over time, we are trying, and all those software vendors are trying to make it more easier and easier. And for those who come to ICANN meetings, there is one dedicated technical meeting which really focus on DNSSEC and all the improvements that are being seen here and there to make it more easier for the technical, I mean, for the engineers and all those people who run DNSSEC. Thank you.
All right, thank you.
Just to add on that, on the software bit, I'd like just to add that they are very actively maintained. You know, you can, if you go to the bind mailing list, you can ask questions about with regards to signing. One of my favorite softwares is from the NLNet Lab guys, which is some of Unbound. They do have NSD. They do have a very it's actively maintained, you know, have new features. Yazid is talking about automation. Obviously, most of the mistakes that have been made with regards to, you know, key expiry and all that, it's always a human error. So for me, I always champion automation. Automation is quite important. Yeah, that's what I wanted to add, Stefan.
Yeah, thank you pretty much. Now let's take the last question because we are 3 minutes over the time. David, this one goes to you. So I would like to know if I need DNSSEC on secondary server, since I already have it on my primary servers.
So, okay, I think here, what happens, the signing is only at one point. So I had mentioned earlier on about hidden, you do hidden operations, right? So you do your hidden operation, you're signing and all that, and then you push the changes to your secondaries. So here it's a bit, the question is not very clear to me, but I would like to answer it in this way. You separate your signing, you do have your signing infrastructure. Once this signing is done, it is hidden, it's not visible to the public, you push it to your public servers. Your public can be primary, secondary, and the like. So there isn't a very clear distinction there. Yeah. I hope
All right, thank you. Yeah, thank you very much. I see it was a very interesting session. Unfortunately, we are at the end of the time dedicated for this. Thank you very much for all those who attended. I just sent the survey link in the chat. So please take a few minutes, 3 to 5 minutes, to fill our survey to tell us what you think we should improve on these webinars, what you found interesting, so that we can bring you more interesting webinars in the future. Also suggest topics. For those who are interested in becoming panelists, please also reach out to us. Reach out to us at events@afrinic.net, and then we will probably discuss with you how we can make it happen. Thank you again to the panelists. Now I will give 1 minute to each of them to bring us concluding remarks. I will start by you, Mr. Ankahu.
Thanks, Stefan. Well, it's quite difficult, but I will try. Let's secure the internet and do everything we need to do from our position. If we are an ISP, if we host domains, etc., etc., security is a real concern, and you have been seeing all those attacks here and there. As I said, many of them are using the DNS weaknesses. So let's secure the internet. Thank you, and back to you.
Thank you very much, Yazid. And now it's time for you, David.
Okay, thank you. For me, my parting shot is thank you everyone for the ones who attended. I know we've not been able to answer all your questions. I think this topic is quite wide, and we appreciate if the interaction doesn't stop here. I think let's be an active community. I've shared my contacts there. I would assist in any kind of way in terms of allowing more people to adopt this DNSSEC, assigning their zones. It's one of the ways for having a secure internet and infrastructure. There are other ways, obviously, but it's important for us to do our part, obviously, on the user's end. It's a shared responsibility. So it's important in any role that we have influence, which we try to assist on this. So I would like to thank everyone who's in attendance. I hope we'll interact online or in person at some time. Yeah, thank you.
Thank you very much. So again, in today's session, we discussed about DNS security, DNS security extension, and you know, it's just a reminder that the DNS is one of the most critical pieces on the internet because it plays like the role of the phone book. Since we cannot master all IP addresses that we use on the internet, it is a very, very, very important feature on the internet. So, but you know now, as Yazid said at the beginning, bad actors are using the DNS system to attack us using techniques like cache poisoning and so on. And to secure this system, we need DNSSEC as one of the practices to secure. So please, we need more people to be activating DNSSEC on their domains, and let's keep the internet secure. Thank you, and see you on our next session. Thank you. Bye-bye. Don't forget to fill our survey. I just added in the chat. So now you may leave at your convenience, but fill the survey before you leave. Thank you. Bye-bye. All right, Wayne, you can end the session.